Everyone's rewriting everything in Rust these days. Discord rewrote their backend and got 10x performance. Dropbox spent 4 years rewriting their sync engine. Microsoft is putting Rust in Windows itself, but Microsoft's own TypeScript team looked at Rust and said, nah, we'll use Go instead. Because it was easier for them to port TypeScript to Go, they answered this, but after seeing Rust being brought up in every discussion that isn't even about Rust, it got me curious. Is Rust really that good, or is it just all hype? So I decided not only to learn a good bit of Rust over the past 6 months or so, but take a look at the entire state of Rust in 2025. What it actually is. No hype, no buzzwords, but performance, memory management, things like that. How it compares to other languages, which I did on a smaller scale, but I want to look on a larger scale. Why people are obsessed with it. It is quite literally the most admired programming language. What the actual experience is writing Rust, and where it falls short. Just a whole look into Rust. That's this video. Let's start with the basics. Rust is a systems programming language that promises something that sounds impossible: memory safety without garbage collection. And why is that a big deal? Well, in C or C++, you can do something like this. Pointer equals malloc, free the pointer, then use it again. This compiles fine, but it's a security vulnerability waiting to happen. 70% of Microsoft's security bugs come from memory safety issues just like this. In languages like Java or Python, you don't have this problem because the garbage collector manages memory for you. But that can come with performance overhead and unpredictable pauses. And Rust solves all of this with this little thing called the borrow checker. Here's the same concept in Rust. Create a box, drop it, try to use it. This doesn't compile. The compiler catches the bug before your code ever runs. No runtime overhead, no garbage collector, but also no memory safety bugs. The result is a language that is just as fast as C, as safe as Java, and as expressive as Python. At least that's the promise. Which begs the question, how does Rust actually stack up against these other systems programming languages? I did a quick comparison building a little CLI application in C, C++, Rust, Go, and Zig, and the differences are telling. C gives you raw speed and complete control, but you're managing memory manually with malloc and free. One mistake and you've got a seg fault or a memory leak. C++, on the other hand, adds modern conveniences like vectors and smart pointers. But you're drowning in a bit of complexity. There are like 6 different ways to do basically everything. Go, on the other hand, strips away all of that complexity for simplicity and fast compilation. However, you lose quite a bit of that low-level control and some of the performance. Although people have been arguing with me about this, you tell me in the comments. And then Zig. Zig has so much potential. It's like C, but with better tooling, compile time safety, but the ecosystem is just tiny, and they've been in beta or whatever you want to call it for, I think, 8 or 9 years. And Zig is very low level. Basically, you're shaking hands with the CPU, which you can buy at Micro Center, the sponsor of today's video, which, as you may know, is the best place to buy PC components, hardware, anything tech. And that does include maker projects like Raspberry Pis. You can get the Pi itself, you can get the starter kits, you can get the project kits, any accessory that you can think of. Or maybe you need a new laptop that has really good GPU in it, and that is the GeForce RTX 50 series laptops lineup available at Micro Center, which, as you can see, they're having some really good deals on, which you can check out at microcenter.com. Use the link in the top of the description, or if you're lucky enough to have one close to you, go there in person, take a look at their cases, take a look at whatever you want, everything that's there. It's an experience. It's worth going to. And if you live in Phoenix, Arizona, or near it, you have one coming to you at the end of 2025 or early 2026. And what you can do is sign up for their VIP days offer for a free 128 gigabyte flash drive. This will also be linked below. Check out Micro Center for any of your tech, PC, keyboard, whatever needs you have. Now let's get back to Rust. Rust sits in a unique sweet spot. You get C-level performance and control, but the borrow checker forces memory safety at compile time. The trade-off is you're fighting the compiler up front in what seems like never-ending bugs. That may just be me. But the alternative is debugging crashes later, and I would take the borrow checker all day long. And are those the reasons why everyone is going crazy over this language? Maybe, but also the success stories are genuinely wild. Discord has this read state service, and it was having 2-minute garbage collection spikes in Go. Users would just see Discord freeze. They rewrote this service completely in Rust and got a 10 times performance improvement while completely eliminating those garbage collection pauses. So for all of you that just commented how much more performant Go is when I said it was up for debate, well, that example wasn't really in your favor. Another example of Rust improving things was Dropbox. Dropbox rewrote their entire desktop sync engine, 4 years of work handling hundreds of billions of files. Their takeaway? Rust has been a force multiplier in our team, so I guess they liked it. Microsoft's Azure CTO said, "It's time to halt starting any new projects in C or C++. We even made a video about Bjarne Stroustrup calling everybody to help save C++ because new projects were not being built in C++, but instead people are choosing Rust." This is one of those examples. These are the people who wrote Windows in C++ calling for new projects to stop being built in C++. They've also rewritten major Windows components, 152,000 lines of Rust for font rendering, seeing 5 to 15% performance improvements, but also addressing the 70% security vulnerabilities I previously mentioned. AWS built Firecracker for serverless computing with Rust. Web development is even using Rust, and you have frameworks for Rust as well as runtimes and whatnot being built in Rust. And of course, CLI tools, that's where Rust really shines. Tools like rip, grep, fd, bat, and x are so much faster than their traditional Unix equivalents that they're switching their entire tool chains. When you can grep through a massive code base in milliseconds instead of many seconds, it changes how you work. And if I were to try to list all of the new things being rewritten in Rust, this video would be a lot longer than it is. So we see the syntax differences and the performance differences and the memory management and things of that nature, but what is it actually like to write Rust code day to day? Because it has to be pleasant to work with if it's so admired and everybody wants to use it. Well, here's a simple function to find the largest item in a list. The syntax looks normal, but there's a lot happening here. The generic constraints, the borrowing instead of owning, all verified at compile time via the borrow checker. Which, when you're learning Rust, fighting the borrow checker, it's a real experience. You'll write code that seems perfectly reasonable, and the compiler will reject it. Like creating a vector, getting a reference to the first element, then trying to push another element. The compiler says you can't modify the vector while you have a reference to its contents. And then you also got to figure out, do you use the vec macro for this or do you use vector for this? And that's neither here nor there, but it's a rabbit hole that I had to go down when I first started learning Rust. The learning curve is real. I coded everything purely as a Java dev with for loops everywhere because I didn't use or know any of their iterator methods. But even aside from that, I'm like, this is cool. Rust prevents bugs. Borrow checker catches everything real quick. But then I'm like, okay, why won't this compile? This should be simple. Then I'm like, okay, maybe I should actually learn what the heck ownership is. And then I'm like, oh, I get this now. The compiler is actually helping me and not preventing me. And I'm like, oh, all of those years of C++, how did I ever survive? But here's the thing is most people say that it takes 3 to 6 months just to get comfortable with the borrow checker. That's a significant investment of time. But I'm inclined to say it's worth it because the tooling is excellent. Cargo just works. Wow. But it's not all sunshine and rainbows. Cargo is very opinionated, whereas Gradle, you can build anything, any infrastructure, whatever you want that your heart desires. So there's a give and a take. Gradle is something you never outgrow, whereas Cargo, I haven't built anything big enough to really tell. But that's enough about Java and stuff. I'll talk about Java in the next video, actually, because Java just turned 30 years old this year, as did I. Anyway, back to Cargo. So Cargo, the error messages actually really help you. They're really good. They help you fix the problems instead of just telling you something is wrong. But compilation times can be rough. Even small projects take 15 to 20 seconds to compile. Coming from other languages with hot reload, this can kind of break up your workflow, but since you use AI to write all of your code anyway, you're probably used to it by now. Even the creator of Flash said, "I really feel like the Rust community suffers from a collective Stockholm syndrome when it comes to compile times." But anyway, if Rust is so great, all of these things, raving reviews and this and that, why isn't everyone using it? First, it's because the learning curve is not just about time, but it's also about mindset, because Rust forces you to think about ownership and borrowing and lifetimes explicitly. If you're coming from garbage collected languages like me, this is a completely different mental model. I've heard one person put this perfectly. They said, "I've seen junior devs excel at Rust with no prior training, and senior engineers struggle for weeks or even months or given up entirely." Because it's not about intelligence, it's not even about overall programming experience. It's whether or not your brain will click with Rust's way of thinking. And the 3 to 6 month onboarding times means that you can't just hire somebody and expect immediate productivity, which creates unacceptable bottlenecks. And not only that, but integration into existing systems, it can be challenging. If you already have Java or .NET or C++ investments, the cost of a Rust integration might not justify the benefits. And then there's that complexity question, because Rust does have a lot of concepts like ownership and borrowing and lifetimes and traits and generics and macros and async await. Each one makes sense. It does. But together, they create that steep learning curve that we discussed. JavaScript developers joke about framework fatigue, right? Well, Rust has concept fatigue. And all of this brings us to the fascinating Rust rejection stories, because sometimes it is a better decision to not use the better programming language, like how TypeScript chose to port to Go instead of Rust. The team acknowledges that they like Rust, but their goal was to use the lowest level language possible that they could ship in a reasonable time. But simply put, if they wanted to port TypeScript to Rust, it would have taken them many years, whereas porting it to Go took them about a year or so. And they tried, because again, they like Rust, but every approach they tried required dropping into lots of unsafe code or devolved into write your own garbage collection style strategies. And the TypeScript dev lead that said that also said Rust succeeds wildly at its design goals, but is straightforward to port to Rust from this particular Java codebase is very rationally not one of its design goals. So yeah, Rust is amazing at what it does, but what it does isn't always what you need. But the reason I needed to address that is because every single time someone doesn't choose Rust or says something about another programming language, they say, why not Rust? But Rust, it is excellent for performance critical systems, for security sensitive applications, and long-running services. It might not be right for rapid prototyping, or teams with tight deadlines, or projects with extensive legacy integration requirements. The ecosystem is mature in systems programming and CLI tools, but not so much in GUI development and machine learning. And while the community continues to grow, adoption is not uniform. You want speed to market, you use Go. You want to create games, you use C++ for ecosystem. Here's my take. Rust, it is a genuinely impressive technology, solving real problems at scale, the performance numbers are real, and the safety benefits are measurable. But technology isn't a zero-sum game. Different problems need different solutions, and organizational context matters more than technical benchmarks. You can't just always say, should I use Rust? Everyone should use Rust, but what problems are we trying to solve? What are the trade-offs of one language to the next? And choose what is best for your use case. I know it's simple, but it's, again, something that needs to be addressed. So is Rust all hype? No. It's worthy of the hype. Maybe not as much as it gets because, again, everything doesn't need to be Rust, but that's fine. Rust is carving out strategic positions where its unique combination of performance and safety and reliability provides clear business value. That's not hype. That's sustainable technology adoption. But I feel like I've said the same 5 things over and over again over this conclusion here. So tell me what you think. Have you tried Rust? Do you like it? And do you think it's worth the hype? That's all I got.